Interference, sustained interference. First one, two light sources of emitting light waves should be coherent. Two sources must emit continuous light waves of same wavelength or frequency. The separation between the two sources should be small. The distance between the two sources and the screen should be large. To view the interference fringes, the background should be dark. The amplitude of light waves should be equal or nearly equal. The sources should be narrow. The sources should be monochromatic. So these are the conditions are required to get the sustained interference. So next, thin film interference by reflection geometry. So here the thin film is parallel plane. So thin film, the monochromatic light is incident on the parallel plane thin film. So the light is once incident on the parallel plane thin film. Some of the light is reflected, అంటే దీంట్లో కొంత భాగం రిఫ్లెక్ట్ అవుతుంది, రిమైనింగ్ లైట్ ట్రాన్స్మిట్ అవుతుంది. ఈ ట్రాన్స్మిట్ లైట్లు మళ్ళీ ఇలా వెళ్తున్న లైట్ సమ్ ఆఫ్ ద లైట్ మళ్ళీ అగైన్ సో లోయర్ సర్ఫేస్ దగ్గర మనకు రిఫ్లెక్ట్ అయ్యి ఎమర్జెస్ త్రూ ది అప్పర్ సర్ఫేస్ ఆఫ్ ది థిన్ ఫిల్మ్. ఓకే, సో హియర్ దీస్ టూ రేస్, సో దిస్ ద ray 1 and this is the ray 2 here. So here the film thickness is small t and film has refractive index value is mu. So here the light is reflected at point B and point C here. Okay, so this is a normal line here. So here once the light is propagating, so here propagating on B reflected in the upward direction and remain light transmitted through film. So this light among the transmitted light, some of portion of the light reflected to lower surface of the thin film. So this will this reflected light emerges to the upper surface of thin film. These two reflected light beams superimpose with each other. So these reflected beams can produce the interference pattern. So here the phase difference is include. So here the phase difference. Okay, here the phase change is included here because here the there are two dense or propagation, that's why. So here there is no phase change here. So here for this we draw the normal line. So what is the angle? Incident angle is I. Here the refraction angle R. So here, so is the incident angle I. సో ఇక్కడ మనం ఇక్కడ ఈ పాత్ డిఫరెన్స్ అంటే బీసీ ప్లస్ సిడి మైనస్ బీసీ చేస్తే మనకు పాత్ డిఫరెన్స్ వస్తుంది. కాబట్టి ఈ పర్పస్ కోసం మనం ఇక్కడ నార్మల్ లైన్ డ్రా చేస్తున్నాము. సో ఈ నుంచి సో ఇక్కడ బీడీ లైన్ పైకి, అలానే డి నుంచి సో బి రిఫ్లెక్ట్ లైన్ పైకి మనకు నార్మల్ లైన్ డ్రా చేస్తున్నాం. సో బేస్డ్ ఆన్ దిస్ వీ కెన్ క్యాలిక్యులేట్ ది సో పాత్ డిఫరెన్స్ ఫ్రమ్ థిన్ ఫిల్మ్ ఇంటర్ఫరెన్స్. ఓకే, సో పాత్ డిఫరెన్స్ డెల్టా ఈక్వల్ టు సో రిఫ్రాక్టివ్ ఇండెక్స్ ఆఫ్ ది ఫిల్మ్ into BC plus CD in thin film inside the thin film propagation here. So minus BZ in out of the thin film. Okay, so in air medium. Okay, so for this we can calculate the BC value, CD value and BC value. Okay, so here this is the right angle triangle, this is the right angle triangle and this is also right angle triangle. So from this triangle so we can determine the so BC value BC. So delta BCH equal, so here the triangle BCH equal cos R equal to CH by BC. From this BC got to BC equal to T by cos R. Similarly CH cos R equal to, so here CH by CD equal to T by cos R. Okay, so plus therefore we can write BC plus BD equal to T by cos R plus T by cos R equal to 2T by cos R. So next we can determine this value BC value. That's why మనం ఈ వాల్యూ అన్నోన్ కాబట్టి డిటర్మైన్ చేయాలి. ఈ సెగ్మెంట్ వాల్యూ డిటర్మైన్ చేయాలి. దట్స్ వై యూ కెన్ టేక్ ది tan వాల్యూ. సో ట్రయాంగిల్ BCH tan R ఈక్వల్ టు సో BH by CH. సో BH opposite side by hypotenuse. Okay, so here the tan R equal to BH by so CH. So that's why you can write BH equal to what is the value T tan R. Similarly CDH second triangle T tan R equal to HD by CH. Therefore HD equal to so T tan R. So here the so value is so T tan R okay, T tan R. So can adding these two terms HD VD equal to BHD BH plus HD 2, so tan R T tan R plus T tan R equal to 2T tan R. So from triangle, so BZD, so here the, so BGD, so BGD triangle, right angle triangle, from this triangle sin I equal to opposite side by hypotenuse, so opposite side by hypotenuse. So from this, so BZ by BD, so BZ equal to BD into sin I. So BD value, what is the BD value? So here BD value equal to 2T tan R. Okay, so 2T tan R into sin I. According to Snell's law, so sin I equal to mu sin R. Okay, so from this we can this value placed in the in the equation. So get the value B is equal to 2T tan R into mu sin R. Okay, that equal to, so 2 mu T tan R into sin R. Okay, so from this can this value placed in the both, so BZ value and BC plus BD values placed in the main path difference equation, you get the value. So delta equal to mu into 2T by cos R minus 2 mu T, so tan R by tan R into sin R. Okay, 2 mu T by cos R minus 2 mu T sin R by cos R tan, so tan kabatti, so into sin R. Okay, so common the issue 2 mu T by cos R, 2 mu T by cos R common this thing. So 1 minus sin square R sin square R. So 2 mu T by cos R into cos square R. So get the value path difference equal to 2 mu T cos R. So here phase change is included, that's why the phase change value phi R lambda by 2, that's why you can write. So including, so 2 mu T cos R plus lambda by 2 is the total, so path difference in thin film. So from this path difference equation we can determine the, so dark fringes or bright fringes. So dark bright condition here, so the path difference, total path difference equal to integral multiple of the wavelength of light. So you can write, so 2 mu T cos R equal to n lambda, so minus simplification cheste 2 mu T, so cos R equal to n lambda minus lambda by 2, LCM 2 n lambda minus lambda by 2, so 2 n minus 1 into lambda by 2, n equal to 0 1 2 and so on. So here also dark condition, so 2 mu T cos R plus lambda by 2 equal to 2n plus 1 into lambda by 2. So 2 mu T cos R equal to 2n plus lambda by 2 plus lambda by 2 minus lambda by 2. You said, okay, minus lambda. Lambda by cancel, 2 cancel. Get 2 mu T cos R equal to n lambda, where n equal to 0, 1, 2, 3, so and so on. Okay, so these are the required conditions for the analysis of the bright and dark fringes in thin film by reflection geometry, interference by reflection geometry. Okay,